Hi, good afternoon. Aw, y'all are so... Hi. Just try that again. Hi, good afternoon.
What's up?
That's a little better.
Hi.
Hi. All right, if you haven't already, please make sure that you get your title and objective written down. This is Chapter 4, Lesson 4 and 5. It is good to be back. I missed you guys. Did you miss me?
I just said I did.
Oh, you did.
Yeah.
Did you go back and watch any of my recorded videos because you missed me?
No.
That's okay, I don't blame you. I didn't either.
You can't miss yourself.
Well, you know,
Yes, you can.
I can.
I miss who I used to be. Psych.
Theorems.
Yeah, theorems. Did I spell it wrong?
No.
Okay.
Is that on the back? Oh my god.
Yeah, I'm starting on the very next. Yeah. Yeah, I'm not doing a KWL on that one. Because the last one was more proofs and stuff. So we're continuing right on. We're doing more proofs, so. All right, I would like you to pay extra close attention to the how objective this time because there's a lot of letters. I kind of went a little ham with the letters today. And all of these will make sense by tomorrow for sure.
This was the last one?
AAS. Sorry. I mean my bad handwriting. All right, without further ado, let's get to it.
Can you make it big?
Okay, my big id. Yes, ready? Tartars. Whoa. Hang on. Okay, there you go. All right, here's the first item for today. It is the side, side, side postulate. And I would like you at this moment to tell your mind to breathe a sigh of relief. This is a postulate, not a theorem. So this is a freebie. You get to use it whenever, wherever, like the Shakira song. And you don't have to prove it. And here's what the side, side, side postulate says. It says, if the sides of one triangle, and leave a little bit of space if you would here on the right-hand side so we can do just a little bit of diagrams. It doesn't have to be a huge amount of space. So if the sides of one triangle are congruent to the sides of another triangle, then the triangles are congruent. And then we're going to draw our diagram. So our diagram has two triangles. So in the space you left yourself, go ahead and draw two triangles. They don't have to be congruent. They don't even have to look congruent because the markings that we're going to put on them will make them be that way. But you want to get two triangles in there. Now this says that the three sides of one triangle are congruent to the three sides of the other. This does not mean that the sides are congruent to each other. Okay, so those markings mean this triangle is scalene. None of the sides are the same size as the other. But in this other triangle, all the sides that have the same number of little hash marks through them are congruent. So all the ones with one mark are congruent to each other, and all the ones with two are congruent to each other, and so on. But they're not necessarily congruent. Like, okay. I got lost somewhere in that explanation, so I'm going to stop. I had enough people kind of nodding at me right before I got lost that y'all got it. Okay. I'm going to step away from the postulates for just a moment and talk about this idea of an included angle. Now an included angle is the angle you get, so it's formed by two adjacent sides in whatever polygon that you're looking at. Okay. So we're going to draw in this little space right here a polygon. Doesn't have to be any kind of polygon in particular. Just make sure that the sides are straight and not curved, and that it closes, and that the sides don't cross over each other, and we have ourselves some sort of funky looking polygon. Now we're going to take two adjacent sides of this polygon. So if I look at this side and I look at this side of the polygon, I have an adjacent angle, and it's always this, or I have an included angle, and it's always this angle that's here inside the polygon. So this is one of those weird angles. It's like a reflex angle. So it's an angle that's bigger than 180, smaller than 360. And it's inside the polygon. Okay, that would be the included angle. This idea of an included angle leads us directly to our next postulate, which is the side angle side postulate. And it says this: if two sides and the included angle of a triangle, let's be specific, let's say of one triangle, are congruent to two sides and the included angle of another triangle, then the triangles are congruent. It is. Today is going to be a lot of writing, I'm sorry. So we're going to do our diagram here. Here's one triangle. Here's another triangle. We should name our triangles. I'm going to... Oh, you're going to give me names?
C.
We already have a name.
Oh.
All right, there we go. We got some triangle names going on. Now I need two sides. So 1, 2. Notice that those sides aren't congruent to each other necessarily, but they are going to be congruent to sides on another triangle. And it wants the included angle, so that's the angle here in between those two sides. Okay. Please pay very close attention to that detail, what is included and what is not included, because these start to become very specific very quickly. And these... It's a, this one here? Yeah, it's a C. Yeah, and then OE. I kind of got into the spine. What is it? I'm all confused.
I live 5 miles away and I have to walk home.
All right. We're going to again take a break from the postulates for just a moment to introduce another new concept, and this is the concept of the included side. Much like the angle, this included side is going to be located, that's the word located, I messed up. It's located between two consecutive angles. Of a polygon. Again, any polygon can have an included side. Please remember that consecutive means one right after another. So there's my crazy looking polygon. Included sides is a side located between consecutive angles. So if I start with this angle right here, the next consecutive one would be this next one over, which makes this side the included side. I'm going to zoom in a little closer on that diagram to make it easier to see. Okay. Again, this concept leads us to our very next and final postulate. Which is the angle side angle postulate. Which says if two angles and the included side, that looks like a D, of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. Oh my goodness, I am off the page. Diagram. Name the triangles.
A, R, Z.
There we go. ARKLZG. This says two angles. So 1, 2, and the included side. So that's the side in between the two angles. Yeah, AKR. I'm out of room on this page. If you have at least this much space available to you, you can continue. Holy cow. If you are out of space like I am, prepare to go on to the next page. I'm going to leave this up there for about another 10 seconds or so.
It's like a shower.
And just zoom that in there a little bit. It is a Z.
I don't like when it goes off and on the rain.
I know, I just wanted to say, like,
Because then you can
It's like
break
a little sweat outside. It looks great.
I South Texas. I don't know.
You know, this winter sucked. It was not
They
cold.
turn on the light switch.
It was cold for like a few days.
For a couple hours, that was our winter.
I know,
Oh,
right?
I went to San Antonio, 43
I went to San
degrees.
Antonio too. It was very cold over there.
Yeah.
Too cold.
I was in Austin. It was even colder.
I was here.
There was ice.
It was 43 degrees up in San Antonio, and I was wearing shorts.
Whoa.
People thought I was crazy.
All right, I'm going to switch the page.
You said it was like
So you think me crazy?
Don't worry if you did not get all of the words or all the details on the picture. My notebooks are available for photo opportunities after lecture. They love having their photographs taken with you. They've been... Huh? Video? Yeah, I'm hoping to get it posted by the end of the day.
Ain't going inside.
It's just no meeting.
Our next item. Tomorrow. Yeah, tomorrow, because I have to go. This next item is the angle side theorem. And I hope that that word theorem puts a little bubble in you going, oh my God, I have to prove this thing.
Oh.
Because unlike a postulate, it's a theorem. You can't take it for granted. You can't use it for free. You will be required to write a proof for this theorem sometime before you leave this class at the end of the year. Huh? Oh, thank you. They're new.
Yes, I have something bad to tell you.
Yes.
I'm not going to use this journal anymore.
Oh, did you fill it up?
No.
No.
I just don't like it
You
anymore.
just don't like it.
Yeah,
She is
I'm using
retiring the journal. Let's take a moment of silence for the journal.
Yeah, I'm using a
Gonna bury it.
Okay. I would like it when you're done with it, though.
different.
All right, so if two angles and the non-included side, let's get my hand out of the way there. If two angles and the not included side of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the triangles are congruent.
This is an if and then statement.
Yeah, this is one of those conditional if-then statements. So it's entirely plausible for you to have a conversation about its converse, its inverse, its contrapositive.
Miss, they all been like that.
Yeah. A lot of your theorems and definitions and postulates, if they aren't stated as if-then, you can write them as if-thens. Yeah. All right, diagram. Two triangles. Names, please.
You see?
Oh. Q. O. P. R. P.
I heard E. Was it P? Oh, I heard E. I'm sorry. All right, there you go. ALQ, DO. DOE. All right, so two angles. Do. Sorry. It's exactly where my brain went. So then we have our two angles. Now notice that the first one is the non-included side. It's not this one. Shh, 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 ladies. It's not this one between the angles. It's any one of the others. But because on this one we've selected the side that is touching the two marked angle, we must select the non-included side that also touches the two marked angle, because it has to correspond. In order, if you're proving triangles are congruent and you want to use this theorem to do it, you have to have the diagram set up to look like this. If they don't, you can't use it. And this is a very important detail I need to stress for you. When you're writing these proofs, you have to make sure that you're paying really close attention to those details, or it's not going to work out for you. We're at the halfway mark. So take a moment. Yeah, we're at about the halfway mark. So take a moment, stretch out your hands, pop your knuckles, roll your necks, whatever you need to do.
Wait, we're halfway done with it?
We're at the halfway mark.
Because we're halfway.
We've been at about 20 minutes. So we're doing okay. We're doing okay. All right. The next part that we're going to do is going to be talking about the same sort of things, showing that triangles are congruent, but it's going to work when we have specific kinds of triangles, one kind of triangle in particular. And in order for it to make sense, we need to do a little bit of anatomy work, so that's how we're going to start this section. And I'm going to tell you that this anatomy portion is going to carry you through all the way into the next unit, in which we do nothing but study the different ways to look at a right triangle. And so we're going to start this next item with the anatomy of the right triangle. We'll need maybe 3 or 4 lines. The anatomy of the right triangle is the single most complicated thing in geometry. Okay? So give yourself plenty of room. Draw a nice big right triangle here in the center. Make it like 3 or 4 lines big. All right. Here we go. You ready? The line that is right across from the right angle is called the hypotenuse. The other sides are called legs. That's it.
Most complicated.
It's the most complicated thing here.
It's like college. Level.
Seriously?
That's it.
Like, seriously?
This is so hard. How did you come up with this?
I don't know. Magic. From this anatomy, we're going to spawn 4. Out of this anatomy, we're going to spawn 4 triangle congruence theorems that are specific to right triangles using the different parts of the right triangle that we just noted here. Please note that since all 4 of these are theorems, these are 4 more proofs that you can be expected to have to be able to write by the end of the year at a moment's notice. Okay? So as we are writing down these theorems, start thinking to yourself, what of the things I've already done could I use to break apart this theorem and explain it? The first theorem is called the leg theorem, and it says this. If the legs of one right triangle are congruent to the legs. Yes, we are going to continue drawing on the side. It's okay if you don't leave yourself space, you can draw underneath it. It's okay. The legs of another right triangle. We will be drawing a little diagram, yes. Then the right triangles are congruent. Spoiler alert, the rest of the theorems are going to end. Then the right triangles are congruent.
Just write that in theory.
Spoiler alert. Alright, so draw our diagram. We're going to have 2 right triangles.
Good.
Please notice a couple things about this theorem. First, it is specific to right triangles. If you have any other kind of triangle, acute, obtuse, isosceles. Well, isosceles, remember, is a side classification, so it could be a right isosceles triangle. Same thing with scalene. It could be a scalene right triangle. It can't be equiangular, and it can't be acute or obtuse. It has to be a right triangle, one right angle and only one right angle. Okay? Nothing else will count. Now it wants the legs, so here are the legs. Notice again that they don't have to be congruent to each other, but they are congruent to the legs of some other triangle somewhere else. Okay? You're welcome to name these triangles if you want. I'm not going to because I'm feeling like the diagram's crowded enough. But if you'd like to name your triangles and make them say funny things to you, you can. The only rule is please don't double up on letters. Second right triangle theorem is the hypotenuse leg theorem. And it says this. If the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and leg of another right triangle. Spoiler. Then the right triangles are congruent. I'm okay if you do want to abbreviate with they are congruent, as long as you know that you were talking about the right triangles and not the parts. Yeah, you can make that shortcut. Diagram. Again, make sure that it's clear that they're right triangles. Try to make them as triangly as possible. Please don't put like 14 sides on these triangles. They should only have 3. No curves either. All right, we want a hypotenuse. That's the side across from the right angle. And we want a leg. A triangle leg, not a chicken leg, please. Take a few more seconds to copy this down. I'm out of room, so I have to go to another paper. If you still have space on this paper, again, about this much space, you should be okay for one more theorem. We have 2 more theorems, to be exact.
After this one?
After this one.
And then we're done?
And then we're done. 2 more, and then we're done. And they're all about the same size as this. Okay?
I feel like we wrote an entire book.
We almost have. Changing the page in about 10. Let me take a drink. You have until I'm done with my drink. All right, I'm going to change the page. Don't forget, if you've missed any of these words or parts of the diagrams, my notebooks are available to you after lecture. They love photographs. They don't charge.
Mine do.
Yours do. All right, second to last theorem is the leg angle theorem. These seem to follow a pattern. You can almost kind of guess what it's going to say by the name. The leg angle theorem says if a leg and the acute, not the, and an acute angle. So it doesn't matter which one. It can be either one because there's going to be 2 in there. Of one right triangle are congruent to the leg and corresponding acute angle of another right triangle then, spoiler alert, the right triangles are congruent. Again, I'm okay if you decide to shortcut and write then they are congruent, so long as you in your mind know that we're talking about specifically those right triangles. Diagram. You're welcome. All right, we need a leg, and we need, on the first one of the acute angles, but on the other one, it has to be the corresponding one. Note that on this first triangle, I marked the angle that was touching the leg that I put a congruence mark in, which means I have to mark the angle that is touching the leg that I put the congruence mark. I cannot mark this other angle because it's not touching that leg. Okay? Has to be the corresponding one. Otherwise, you're not able to use this theorem. You don't have the information that it's requiring in order to use it, so you won't be allowed to use it. You have to be really, really careful with those details. Again, I cannot stress enough. Super, super important that you pay attention to those little tiny details. Last theorem. Our last theorem is the hypotenuse angle theorem. Can you guess what the setup is going to be on this one?
Hypotenuse corresponding with
Yeah, something about a hypotenuse and one of the angles. You're right. So if the hypotenuse and an acute angle of one right triangle are congruent to
was right.
the hypotenuse and acute angle of another right triangle then, spoiler, the right triangles are congruent. Again, I'm okay with the shortcut, as long as you know we're talking about the right triangles. Diagram. I need some right triangles. All right, this says the hypotenuse and an acute angle, and it doesn't say that it has to be the corresponding one, mostly because if I accidentally pick one that doesn't look like it corresponds properly, I can do some sort of flip, a reflection, right? And that transformation, since reflection doesn't change the size of the thing, it preserves congruence. It's isometric. I'm allowed to do that, and I can still hold on to my congruent statements. Okay? Any questions? That's all for lecture today.